and we picked up a bunch of birds, and we turned right back around, road trip back down. Nice bonding experience. So we used these birds, and we set up a colony in the lab. So zebra finches, tell you a little about them for a second. They're originally from Australia, the deserts of Australia. They're pretty small, only about this big. And they only sing one song. There are lots of birds out there that will learn multiple songs, but these guys, they just learn one. It's pretty simple. Let's see, they're also really well adapted to captivity. In the wild, they have a lifespan of about 1 to 2 years. In captivity, it's like 5 to 10 years. And that's because they are pretty defenseless. Their only defense is really that they live in colonies of like 40 to 60 birds, so it's kind of a numbers game. Like, if you're gonna eat me, it's, well, if you're coming to eat us, it's probably not going to be me. For now. So in captivity, they actually feel really safe and secure. And also, since they're from the desert, they don't really experience seasons like a lot of bird species do. Most species will sing a lot more in the spring because that's when they're breeding. Zebra finches, because they're just in the desert and don't have these huge seasonal fluctuations, they're instead what we call opportunistic breeders, in that their only real cue is like, is there water? When it rains, they're like, all right, let's go. There's about to be enough food around, and like, yeah, good times here. Water is the ultimate aphrodisiac. So all these reasons make zebra finches a really great organism to work with. So in the lab, what we do is, so we breed pairs, and we then, once the babies hatch, when they hatch, they're about a gram. They only weigh about a gram. They're like super small, about honestly the size of like your thumbnail. It's pretty incredible. But they grow within 30 days up to almost their full adult size. So it's pretty incredible to watch actually happening. So the way we test this like stress hypothesis is by actually just directly giving them the stress hormone corticosteroid. It's basically the songbird version of our cortisol, and we give it to them while they are in the nest between 5 days old and 12 days old. And during this period of time, they're like, completely dependent on their parents, and they are basically just begging for food, and that's the only way they get their food. So it ends up being really, really easy. They are very willing to accept the treatment, and we give it to them dissolved in peanut oil, which they're like, heck yeah, peanut oil. So it's like a pretty, easy way to actually do this and get at the root cause of like, what is this hormonal change that's happening. So after that, 7-day period of treatment, we leave them alone, let the parents raise them up the rest of the way. And then when they turn 35 days old, we take at this point, they're nutritionally independent, they're flying around, they're actually look like a bird rather than just like a little alien that's the size of your thumbnail. And we move them into their own recording chamber. Basically, we built these 24 chambers they're about the size of an igloo cooler because they are igloo coolers. We have lined with sound foam, outfitted with microphones and light timers and everything that a bird needs, and we lovingly call them the smallest recording studio in Nashville. So they go into there with their own personal adult male tutor, and once they're in there, we record every sound they make for the next 60 days. And what that means is that we catch every bit of sub-song that they're singing from the very beginning, and when they're these totally random noises, all the way until they're almost adults and are singing these fully formed songs. So that allows us to not only see how well they ended up learning, but what happened along the way. What kind of mistakes did they make? How quickly were they able to correct any mistakes or land on the right syllables and the right sounds? So that's kind of how we do that. And ultimately, my goal is to take samples of where we look at the actual genes that are being expressed differently after this stress. And so from that, we kind of want to see like what is physiologically changing based on this stressful experience that is actually happening in the brain, leading to all the other symptoms that we end up seeing later in life. And who knows, we might be able to get something that we can then translate over to humans. Talk to you a little bit about
Yeah, no, if you want to get in there, I can start recording. You think you can fit?
I'm gonna try. It looks quite small.
Yeah, I'm here for the session.
Yeah. Well, do you need a bassist along with you?
Yeah, it looks.
So we should have headphones and cues for everybody in there.
Oh, I got mistakes. Can I join?
Yeah. We can make room for you.
Yep.
All right.
Ready?
Ready to
Sorry,
go?
sorry, I'm late. I got the...
Oh, the saxophone, yes, of course.
There we go.
All right. Did you have anybody else along with you today?
Well, I think.
Oh, hi, it's me, Yoko. I'm just gonna take this one.
Who else can make do, Rob? You can pick up the slack.
No, Nevin was kind of the,
Yeah, it was the main
kind
thing.
of the man.
He's everything.
Well, Yoko, do you think you could maybe like
Just
5
join
minutes?
us.
Just bang out a quick
Oh,
tale.
just Yoko? Okay.
No!
Oh,
Do you know the
join
parts,
us.
darling?
There's so much room in here. Come on.
All right, I'll come in.
All right.
Oh, good.
All right.
That was way easier than I thought it was gonna be.
Is everybody comfortable? Anybody need any water?
Can I get water?
Yeah.
Okay. How about 5 little waters and a little recording studio?
Come on in. Can you bring it all the way in?
Okay. Do you want me to pour it in your mouth as well? Jesus Christ. Okay, great. Yes. Okay, is everybody ready?
Can
Ready
I
in time.
get pretzels actually? You know the ones that they get.
Oh, the ones that will be really loud in the microphones? No.
I've got a bag of Lay's.
Okay, make sure to keep the crinkling away from the microphone.
You thirsty, babe?
All right, we're rolling.
We're
rolling.
Oh, you're recording every little sound.
Yes, of course. I think we've got a hit.
Hi, Doctor. I've been a little stressed since I've been about 10 years old. My arms haven't grown.
Ah, yes, we call that no arm syndrome.
My mom painted my room purple and it stressed me out too much.
When will they learn?
And because I have small arms, I can't get a job, so I have to keep living in that purple room.
Poor dear.
Dr. Finchmeister, tell me you can give me something else. Tell me I can grow them now.
Let me look at my selection. I can give you a pair of giraffe arms.
Can I walk with them?
You can do with them whatever you like. Here's our simulation.
Incredible. I can almost reach the trees if I balance on my front legs. I don't even need my actual legs.
Let's not settle on our first choice. Let's look at other options.
Okay.
Ah, yes, silverback gorilla.
Wow. Oh, they reach very long. Oh, I'm eating a banana. Does anybody work here? Oh,
Hi, welcome back.
hi, thank you. Yeah, so the last guy you gave me didn't work out so well. I'm gonna need to see some new men.
Oh,
Yeah, I just what's the best you've got?
well, let's get the catalog out. I mean, absolutely.
Well, I'm so sorry. Was there a particular problem?
Well,
I mean,
he was too tall. Like I had to stand on a stool to get up, and it was a lot of work for me.
okay, the height thing.
Yeah, just
okay.
Yeah.
Okay.
I'm not picky though, you know. I'm not picky. Maybe somebody with some a full head of hair. Maybe.
Okay, yeah. Here's Jeremy. He's 5'8". Okay. Yeah.
Okay. Do you have him? Can I test
Yeah,
him out?
right there. We've got
Jeremy, you said?
Jeremy right there.
Okay.
As you can see,
he
raised in
looks
a good
nice.
nest.
Squawk, squawk.
You know, he's kind of got a scraggly voice. I think. Again, I'm not picky, but maybe not Jeremy.
All right, goodbye, Jeremy. All right. How about this Bob right here?
Oh.
Mm-hmm.
Okay.
Yes.
Yeah. Okay, that's
I
fine.
know, a condensing song. Yes.
I mean, he's kind of intense. Okay, I think I can try Bob out. Can I keep coming back and returning? I mean, how many returns do I get?
We have a 35-day policy because after 35 days, they're pretty much set in their ways.
Okay. Well, I think I can work with Bob for a little bit. Well, I mean, for the rest of my life. It was raining today, baby.
You know, I love the rain.
It's such an aphrodisiac for us. Really makes
I haven't
me want
felt
to
felt this on since that one time we went to the Pacific.
Remember we took that long drive and we just talked about our lives and bonded? It was so nice. It was the first time I felt really connected with you.
Cut to the drive.
I love this standing ski boat. You know,
It's gonna look like one day.
say again.
You think it's what our honeymoon's gonna look like one day?
I want a honeymoon in the Red Sea. You know, I'm a little disappointed. I thought it would be red.
So for our next segment, we're gonna have Kate Snyder come back on. Can we give a round of applause? Okay, so I'm going to talk about now a little bit of a pivot to the work that I do when I'm waiting for birds to grow up and learn songs. Because if I were to just sit in lab for 60 days while listening to birds just learn, I might not get very much done. So I have another project that is also related to birdsong evolution. This project, when I'm kind of doing the day-to-day, I look a little bit less like a biologist and honestly more like a computer scientist type thing. So this one is all computational. Basically what I've done is I've researched just kind of hundreds of species of songbirds. And I've looked up, I've looked through the previous literature, just looking at scientists that know these specific species really, really well. So I compiled all that data and basically was looking for two different types of data. First, I was looking for different features of these species' songs. So these are features, specifically the one that I was looking at mostly is called syllable repertoire. You can kind of think of it as like a songbird's vocabulary. And so a songbird with a higher syllable repertoire, basically we kind of use that as a proxy for complexity. So they are probably singing more complex songs, maybe more attractive songs. So in all the birds of the world, there is a lot of diversity in songs. So you have like your mockingbirds that can sing almost like infinite syllables versus your zebra finches who typically know about like 3 to 4 each. So I wanted to know like what has kind of contributed to this difference in evolution. Because in theory, if birds are always selecting for more complex songs, then you'd expect that like all birds these days would just be like really complex, right? I don't know, but that's clearly not what we see. So I wanted to look back into their evolutionary history, see what might have contributed to the diversity we see today. So collected data on songs. The other thing I looked at was mating system. So what's kind of rare in the animal kingdom, but not at all rare among songbirds, is that songbirds are mostly socially monogamous. They typically pair with a mate, and they stay paired for some amount of time. So cardinals are an example of this. They stay paired for a pretty long time. Zebra finches are also like this, actually. But then there are birds that will like pair for maybe just one breeding season. Then when they migrate, they kind of go their separate ways. So that's how monogamy works with them. But the remainder are mostly polygynous, where it's very common in those species for a male to mate with multiple females. So maybe he goes to each nest a little bit at a time, or maybe he just goes to one nest and the other one is just kind of nearby and benefits from his just kind of territory defense. However it happens, in this scenario, you have a species where females are not necessarily looking for an exclusive mate, they're looking for the best mate. So when we're talking about sexual selection, you might expect, as even all the way back to Darwin, as he did, that in monogamous species, a male would have to have a pretty attractive song, a pretty attractive whatever it is that he uses to attract mates. But even if it's not like the best, he will still probably get a mate as long as they're about equal numbers of males and females. But in a polygynous species, if you're a really attractive male, you could potentially be mating with like 2 or 3 or even more females and really succeeding a lot more, evolutionarily speaking. And if you had a crappy song, you might just like be out of luck and not get to reproduce at all. So, in theory, in polygynous kind of lit species, you would expect there to be higher sexual selection on males' songs or plumage or whatever it is. So I collected data on all these species' mating systems, so whether they're monogamous or polygynous, and then also whether they have low or high levels of extra pair paternity. And that's basically where females will go away from their social mate and solicit mating from another male. It's kind of thought that this might be adaptive because then she has offspring that are more genetically diverse. So whatever kind of environmental change happens later, she'll, maybe one male has some genes that are not well adapted for some environmental change, but the other male did. And so kind of diversifying, not putting all of her eggs in one genetic basket. So whether they have higher or low extra pair paternity. So I did some computational analyses. Basically, what we do is we take the phylogenetic tree, which you can look at online. It's at birdtree.org.